Well, hello everyone, and welcome back to Adrian's Digital Basement. It's been a while since I've had anything IBM on the channel, and I'm not sure I've actually ever had anything that was a PS2. And believe it or not, this is an IBM PS2. It appears to be a miniature PS2 computer from around 1992, and it is type 9533-DB7. I don't know a whole lot about it other than, as you can see, it's got a little flip down cover here on the front. A friend gave this to me along with a bunch of spare parts, which I have sitting here on the bench. I don't know if this computer works. I don't really know its specs, but I have a feeling that this might make a good small form factor retro gaming PC. And the reason why I say that is because it looks like it has an ISA slot on the back, which means, of course, you could stick a sound card in here. The thing is this thing filled with all the usual IBM proprietary tech that a lot of PS2s had, or is this thing using somewhat industry standard interfaces inside so we could put a normal sound card and a normal hard drive and stuff in here? So on this video, we're gonna take a look at this thing, see if it works, see if I need to use any of these spare parts to get this working, and then figure out if this thing is a viable miniature DOS PC. So without further ado, let's get right to it. So from the looks of this thing, I would say that this was probably targeted at some kind of a business market designed for just like small form factor computing, maybe even as much as like a thin client or something. Now, the reason why I think this is from 1992 is I did take a peek at some of these cards here, and there was a spare motherboard here on the bottom, and this appears to have a 1992 date code on it. But I haven't looked at this thing in ages, so I don't even know what kind of CPU is on here. I really don't know anything about this machine. So we'll be discovering this stuff together. Looking at the front of this thing, it doesn't have the normal PS2 appearance, but it does say PS2E right here. E for embedded. Then we have a power switch and a hard drive and a power LED on the front. There's a key lock cylinder here. I don't have the key for that, but luckily it's in the unlocked position. And you notice the little indentation here, which we can push down, and it flips down, which exposes a 3.5-inch floppy drive. And this is the type that would be inside a laptop. So it's a little thin type. And then we have an opening here, which I can presume is something like a card slot for maybe PCMCIA. On the back of the machine, you notice we have an internal power supply, so IEC mains input, which is pretty cool for a machine this small. There's the exposed slot cover for whatever slot is in this thing. Is it ISA? Is it microchannel? I guess we'll take a look inside and see together. We have a VGA connector here. It might be just MCGA for all we know, but it looks like it has that extra pin that is filled in on the connector, meaning not all modern VGA cables will work in this. You have to rip out a pin to plug it in. Mouse and keyboard PS2 ports. We have a parallel printer port and an RS-232 9-pin connector. Now, when I got this computer, the cover was already like this, where it's been partially removed, and you just slide this forward and then this lifts off. And inside that exposes what's inside of here. Well, that's exciting is right off the bat, ISA slot. Now, it's funny because, I mean, that looks microchannel-ish, but obviously you can see the pinout just going straight to it. We'll go poke around online looking at the model number shortly to see if this thing maybe came in a microchannel version. Looking at the construction of what we can see here on the motherboard, this is very much an IBM. IBM RAM, and I mean, that looks like 72-pin RAM. Hopefully that is somewhat standard. And we have a CR2032 battery for the CMOS. That is a good sign. This RAM here is probably for the video circuitry, which I suppose is some custom IBM stuff. This is what I don't like about PS2 models is IBM went highly integrated with all their PS2 machines. And if any of these chips go bad, and they do occasionally, you're pretty much up a creek. And the only thing you can do is salvage one off one of these machines to try to get the machine working. Looking at this stick of memory here, a 4M would make me think this is 4 megs of RAM. Look at that font there, MEM2 with all the little serifs. Very fancy there, IBM. We can see the date code here, 1992, 36th week. So we know that this thing comes from at least then, probably a little bit later. Look at this power supply, made in Scotland. It's an IBM power supply, max power 24 watts. This is one low power little computer. I wonder if there's even a fan inside of here. This thing might be entirely fanless. Now it appears the power supply and I guess the hard drive maybe, if it's underneath here, and the floppy drive is on this tray. And it looks like the floppy drive uses this ribbon cable, which is not connected at the moment. And we can see another ribbon cable down here, which I'm hoping is a standard IDE cable that is just sort of split. And I don't know if it's actually connected to something, but it might actually be plugged into something, which is good because we need to see what kind of hard drive this takes. Is it proprietary or is it not? I have hope that maybe it's not proprietary based on the fact that this thing has an ISA slot. Now, I'm very inexperienced when it comes to IBM PS2s, and I have one PS2 here in the basement that I've never actually shown on any videos because it just works, and it's an IBM PS2 Model 30. I'm pretty sure the Model 30 was either a 286 or it could come in an 8086 or maybe an 8088 variant, and it didn't have microchannel. That was one of the things going for it that is kind of nice, is it uses normal ISA slots, so it is possible to install an XT IDE into that thing, so you can get away from using the customized IBM hard drives that use a kind of an edge connector, and I don't know how reliable those are, and I think they're pretty hard to find, and spinning drives, of course, are just super unreliable. I do know on the more conventional PS2s, the one with the PS2 good looks, they came out in the late 80s, and they have floppy drives, which I think are made by Sony. Maybe there's another brand as well that have SMD caps that leak. So those floppy drives tend to always be not working or non-functional, at least until you clean them up and recap them. Hopefully this drive that's in this machine, which if you tilt this up, you can see here, it's a very thin little laptop drive. It looks like it's a little worse for wear with a bash right there and some dents on the top, that this maybe actually works. And the button here says 1.44, so we don't have any kind of fancy high capacity drive. Looking down there, is that a hard drive? Is that just a laptop hard drive down there? If that's the case, that's excellent, because that means we could just use a compact flash card if this is nothing proprietary. Let's keep our fingers crossed. On the bottom of the machine, this just confirms again the type and model number, 9533 DB7. There's a serial number, FCC ID, etc., etc. Does say it was assembled in USA, but we saw the power supply came from Scotland, so who knows where the other parts came from, and we have a multi-voltage power supply, which is handy. So right now, we're only able to see about half the motherboard. Clearly, there's stuff underneath this power supply tray here. I don't know what kind of CPU this thing runs. I haven't looked up the type number online to see the specs of this thing, and we can't see a CPU over here. Now, a few things are giveaways about maybe the type of CPU this thing has. We have 32-bit memory slots here, these 72-pin SIMs, which kind of implies that this thing is going to have a 32-bit processor, so a 386 or 486. And based on the fact that this thing was from around 1993 or 92, well, there was no Pentium at that point, so this thing either is a 486 or less. And a 486 would be pretty big and somewhat power hungry, and we saw this thing only runs 25 watts. So I don't think it would be a 486 in here, but then that begs the question, why does it have 32-bit memory if it's not a 486 or I guess a 386DX? And looks like we can see a little bit of a heatsink there. Well, okay, let's go look up the specs online and see what CPUs this thing was offered with. All right, quick Google for the type did bring us right to Wikipedia article. PS2E for energy. Wow, that's really interesting. It was the first Energy Star compliant PC, consuming very little power relative to other contemporary PCs and made extensive use of recycled materials in its enclosure. The PS2E featured an IBM 486 SLC2. All right, well, that sort of gives us what we needed to know. The SLC2 is just a 386SX, but it has internal cache, as it says right there on screen, which allows it to operate more with the performance of the 386DX. Very interesting, though, that IBM is using 32-bit memory, or what appears to be 32-bit memory, on a CPU that absolutely has a 16-bit data bus. So there must be some extra circuitry here in the chipset to make that interface possible. 16 kilobits of L1 cache is very high for a 386SX type processor, and it's clock doubled, running at 50 megahertz on a 25 megahertz system bus. I wonder if there's some hidden jumpers for overclocking on here to bring this up to a 33 megahertz system bus and give us 66 megahertz. This article confirms that it used ISA bus, as we've already seen with this little riser card. Depending on the submodel, came equipped with a special option for 4 PCMCIA cards or a network interface card for Ethernet or token ring. Other optional accessories are a color LCD and an LCD touchscreen with a special version of OS2. Borrowed components from the ThinkPad line, like the floppy drive, that's exactly what I was thinking. It says it has 1 meg of video memory for onboard XGA2 graphics. 1 meg does make sense when we look at these 8 packages here. These are zip packages. 2 of these are probably 256K, so that's 256, 512, and then a megabyte total with a 32-bit width as well. So for decent performance potentially, and maybe that's the chip handling the XGA2 graphics with the 1 meg of video memory. But I missed this line here. It says the XGA2 graphics is connected to the ISA bus, so 16 bits versus the MCA, so worse performance theoretically. Like all PS2 systems though, if a change of hardware is performed, the configuration must be updated with use of a reference diskette. Wow, okay, well that means I'll need to find that disk to get this thing doing anything, I guess. Now I don't know how accurate this is, but it says over here, estimated units sold is only around 25,000? That's a very low number. That means I guess these things are somewhat rare. And the release date was July 29th, 1993. All right, so there was a link at the bottom of Wikipedia, the article that took me to this page here. It says that this thing does have a 16 meg RAM limit, which is completely understandable. That's because of the package for the CPU only gives 24 address lines. And it can support 8 megabyte 72-pin memory, but obviously with 2 of those, that's 16 megabytes, and the onboard 4 megabytes becomes unusable, so it will only use 12 megs of the socketed memory. So IBM is doing some fun trickery there with those custom ASIC tip chips they have on here. It does say that generic or industry standard memory will not work. It must be PS2 style 70 nanoseconds memory with parity. Well, we'll have to test that to see if I can just find some parity 72-pin memory and see if it works on this thing. Hard drives, it will accept any normal 2.5-inch IDE hard drive. Excellent, that means we can use a compact flash card. It has the usual problem with machines of this age that it only supports drives of 512 megabytes. This little section here is pretty hilarious. Obviously, this poster from whenever this article was written didn't like Windows because the XGA2 driver for Winblows is for the MCA version, and this machine has an ISA XGA2 and it seems to not work well properly together. I managed to get it working under Windows 95, if I recall correctly, but I deleted WinCrap from it and installed Linux. XGA2 has 3 apertures or direct video buffer access paths, 64K movable window below 1 megabyte, a 1 meg aperture below 16 megs, and a 4 meg aperture just below the 4 gigabyte line. Now here's something that's interesting. This says it's an ISA bus system, and in common with other PS2 ISA systems like the Model 30, it does not use a reference diskette. It does have a starter disk and a utility disk, which contain, amongst other things, management utilities and drivers for the 4-slot PCMCIA adapter that some models shipped with. And there's a outline diagram of the PCMCIA adapter, which I'm pretty sure I have in this pile of parts here. This probably means it's possible to use the PicoGus that is designed for little IBM portable computers with this machine, theoretically. That'd be interesting to explore that. It's pretty cool this article is still available online here because this is all excellent information that's all been preserved. I think what I'll need to do is go find the disk images, so if this thing does work, we can get it working, then I can at least boot that advanced diagnostic or whatever it's talking about here, which I'm assuming, even though it's not a reference diskette, it's probably like a BIOS setup disk. So one thing I want to mention here is what I like to do if I find a page like this that's clearly hosted on, you know, who knows what this server is here. I like to save this stuff. I keep it in my Google Drive just in case it ever goes offline. And if it links to any downloadables, I'm going to grab those as well. And that's because Internet Archive obviously is around today and working, but there's always the possibility that Internet Archive won't be around. And the other possibility is that they didn't grab the downloadable files. So I always like to grab everything I can, which I'm just going to save that here, just in case. And indeed, on this page are the links to these various disks and stuff. So let's hope that these are still available. Incidentally, it looks like this was paired with a specific Energy Star IBM PS2 monitor. Take a look at this photo I found here. I don't know if this is the exact monitor we're talking about, but look at that thing. That is so early 90s LCD, but I kind of love it. It must have cost a ton of money. And yes, this is it. The 9507 color display is a 10.4-inch active matrix flat panel display. It was a TFT monitor and dramatic reduction in physical size, weight, and power consumption. Obviously, the whole idea of this thing was extremely low power. And it seems to say up here that the whole thing with the monitor consumes less than a 60-watt light bulb. In a way, it's kind of funny to think about this, that they were really trying to achieve such low power consumption back then. And that's almost certainly why they went with the 46 SLC2 chip, because I think that thing would have been the lowest power device versus a 36DX or a 46, a real 46. And obviously a 10-inch LCD monitor, even with the inefficient backlight technology we had back then, would have been a lot lower power than a CRT. Almost certainly the panel that was used inside the LCD monitor was just the same one that was used in the ThinkPad. They just put it in an external case. A lot of what we're seeing here, including like the floppy drive here and the laptop hard drive, is just sort of laptop technology shoved into a case for your desktop computer. Maybe this machine was the first example of that, which now is really common. We have all these like mini PCs that use APUs from AMD and laptop style processors from Intel that are really tiny and are essentially that, just laptop technology all just shoved into a little tiny brick computer. Well, this might have been what kind of started it all. And if you're aware of stuff that was earlier than this, that was trying to do that using laptop technology in a desktop computer, I'd love to hear about it in the comment section. Yep, take a look at this. The very first IBM ThinkPad, the 700, came out October 5th, 1992, not long before this PS2E. And look, one of the optional processors on the ThinkPad was the 46 SLC2 at 50 megahertz, same as this computer. And look, the 700C came with an optional monitor, 10.4 inch, 640 by 480 active matrix screen. Likely the same panel and guts as the external monitor for this computer. I suppose one difference here is that the ThinkPad came with a Western Digital chipset for video, while the PS2E has the IBM XGA chipset. Now, there was also apparently a CRT here. Designed with energy efficiency in mind, this color monitor introduces power management capability that meets the power consumption requirements for EPA Energy Star program. And it's funny because it doesn't actually have a model number for this, so I can't really look it up, but my assumption is that this looks exactly the same as all the other IBM PS2 monitors at the time. It's just that it would have this sleep circuitry added in that the computer could then, using signaling over the VGA connector, shut down the monitor. And I'm actually curious, is that also the first monitor that had Energy Star? To this day, that standard is still followed. If I plug in any monitor that's out today that has a VGA connector on it into this computer and it tries to put the monitor to sleep, 99.9% sure it will turn the monitor off and it will go into the sleep mode that we're all super familiar with. But in 1992, this stuff was pretty cutting edge and brand new. Otherwise, when a computer like this tried to turn the monitor off or put it to sleep, or you just shut the computer off but you left the monitor on, the monitor was still running and generating high voltage and generating heat and using up almost as much power as it would be if it was displaying an image. We sort of take for granted now that you never have to even think about turning your monitor off. It just happens automatically when you turn your computer off. But that was new when this thing came out in 1993. And I guess IBM was sort of pushing the boundaries there. All right, here's a little bit more information about the different models. So we have the DB7, which was pre-installed with DOS 502 and Windows 3.1, and it had the PCMCIA card in here. But you could optionally get it also with OS2 2.1. You could also get it without a disk drive or hard drive, but PCMCIA, that's the GB7. And 1BX is an ISA Ethernet adapter, no disk drive or hard drive, and then the 2BX has token ring with no disk drive or hard drive. So just keep that in mind if you're looking to buy one of these for yourself, that you should avoid the models that don't have the floppy drives at least, because you'll have to then figure out how to get a working floppy drive on this. And if the cable's not in there, you're gonna need that weird ribbon cable, whatever this thing uses, to hook that ThinkPad style drive up to the motherboard. And looking down here, you can see that the fact this thing had up to 4 PCMCIA slots in it, it's pretty great and pretty expandable. Ethernet, solid state mass storage up to 15 megabytes, I guess like a flash drive, so to speak. Also little mini hard drives as well that plugged into PCMCIA. Of course, you get Ethernet cards, token ring. And we know there was a ton of third-party PCMCIA devices. Ethernet cards specifically, there were sound cards, SCSI cards, and these little adapters, which you can still get these days, which are compact flash adapters, where you just stick a compact flash card into the adapter and you pretty much get an IDE hard drive without too much fuss. Now, what I'm unsure about with this thing is if you can boot off of these. Probably not, because I think what has to happen is you would use an internal hard drive and it would begin to boot the system, and then a driver needs to be loaded that then activates the PCMCIA in DOS, for instance, or for Windows 3.1, it'd be the same. And then you could access the additional storage on your compact flash cards. But in a way, it's pretty interesting to think about because there is a picogust that is in the form factor of a PCMCIA card that would just stick out of the back of the computer and then give us all the sound card options. And then possibly we could get an Ethernet card working in conjunction with the picogust sticking out the back of the computer. So that means some pretty serious expandability might be possible with this thing. But I think I'm really getting ahead of myself now. We've kind of learned about what this computer is all about, but I don't even know if this thing works. So let's go take a look at these spare parts here, and then let's try to fire this thing up. Right, so these are the spare parts that I was given with this machine. Looks like we have 3 of the PCMCIA adapter cards, and interestingly, one of them is smaller than the others. Oh, I see. This one here, the larger one, has the card slots that stick through the front of the computer behind that flap, and also have slots on the back. But this one here appears to only have maybe 1 slot on the back, plus 1 slot internally. And then we have an additional tray here with the power supply, which is excellent because in case there's a problem there. And there even appears to be this, the cable for the hard drive. And what's interesting is, okay, that's the power. So the power comes off of here and it feeds to hard drive because 44-pin IDE connector for laptop drives has integrated power, 5 volts. Then it appears we have a spare floppy drive. No floppy drive cable though. And here is the spare motherboard. So this is awesome. This gives us a look at the part of the motherboard we weren't able to see. What is this? Is that some kind of math coprocessor socket? I'm not particularly familiar with that. This must be the CPU right here. Let's take a look on the side. Yep, that is the CPU. That looks like the footprint of the 36SX. Normally the math coprocessors for 36SX have a PLC type socket. I've never seen a PGA or pin grid array math coprocessor for one of these chips. There's a date, September 2nd, 1992. There's the FRU number 10G3966, IBM Corp, 1992, Civ Embed. Looks like they're using some Intel parts here, an Oki chip there, another large VLSI chip here. You can see like the integration that's going on with this thing is pretty high. This obviously tells us here, and it wasn't listed, but they thought about adding SCSI, so internal 50-pin connector and an external SCSI connector, which would explain why there's a big empty space here on the back connector. Also, indeed, as I kind of thought, we have room here for another 9-pin, and these chips here are probably for supporting this extra serial port. IBM obviously had some ambitions for this line of computer to really take off, but I guess the fact they only sold 20,000 of them means that it was really a flop. And the article on Wikipedia and the other page we looked at didn't really mention that there were any more of these computers after this, especially any that added this functionality here for the SCSI adapter. The 2032 battery that was in here did not leak, which is a good thing. Let's see if it has any current in here or any voltage stored in there. Nah, that is dead as a doornail. Take a look at the PCMCIA adapter. This thing is a beefy beast. So we do have 2 slots that stick through the front of the computer, through that trap door, and we have 2 slots on the back of the machine as well. This obviously plugs in like that, and there's not a whole lot of room on the bottom, although there's a little bit. Wow, look at the back of this thing. This is loaded with chips as well. And here's the other card that was included here, and I don't think this is actually an IBM part, so this probably didn't even come from this computer. This is probably just unrelated, just was thrown in here because it is PCMCIA as well. If you recognize this and you know how I could possibly use this, definitely let me know. Okay, enough talking. Let's test this thing out. So I'm gonna try to, well, let's just power this up actually first before I even hook the floppy drive up. This machine uses an actual latching power switch. Judging by the fact that these cables here are very thin, it looks like this little ribbon carries the hard drive LED and the power LED along with the power switch. So it probably goes to the motherboard, I'm thinking. And looking at the spare motherboard here, this is obviously for the main power rails, but I'm assuming this ribbon cable here probably plugs into one of these connectors, and the power supply probably uses the other one, and then that's how the motherboard is able to tell the power supply to turn on and probably engage some kind of low power sleep state. That means that it's quite possible this power supply is very custom and wouldn't be easy to replace, you know, even if you swapped out the guts if this thing weren't working, specifically because of probably the soft power on capability it has, but also the low power sleep state it has. Maybe an ATX power supply could be made to work, like maybe there's a 5-volt standby that goes into here. I came across this other website here, which has more information, or I didn't see this on the other one at least. We have the pinouts for the power supply. So yep, 5 volts, all that goes to the motherboard on the main connector. And then we have a little small P2 connector, which does have 12 volts, minus 12 and 5. And then we have the power on off signal that I was talking about. It comes from the motherboard, does the soft power on and a power good signal. Okay, so mains input plugged into the back there, and I'm gonna plug it into the wall. Nothing bad happened, so that's a good sign. Let's push the button on the front here. Hey, the hard drive spun up and the green power light's on. That's cool that the hard drive is working. That means that potentially there might be some drivers and stuff on there, or an OS that actually boots like into Windows, and I don't need to go and custom install Windows and get everything set up for this weird specific machine. We might just have a working computer. Okay, it's probably complaining about the fact that there's no keyboard, no mouse, no monitor plugged in, and no floppy drive, of course. So let's get this plugged in here. Okay, I think that is finally in there. For capturing VGA, I've already ripped out the pin on the back. I've done this a long time ago because I have other video cards that have that blocked off. You have to do that or you can't connect the cable. Just get some needle nose and wiggle that out. I hooked up this cheap PS2 keyboard and an HP PS2 mouse, and we are good to go for testing. Let's turn this thing on. There goes counting up the RAM. It's very IBM, isn't it? With so basic looking. This thing should have 8 megs of RAM based on what I see on the motherboard and that sim. 161. Well, the floppy drive seeked. Oh, is that probably telling us that the battery is dead? I didn't change the one on this one. That battery there. Right, not okay. See documentation. Can we just push F1 to start booting? Yep, there goes, DOS 5 shell. Nice. Well, one thing we can see for sure is that this thing does not have Windows on it. It doesn't look like it has anything on here. It's like been unused or it's just factory defaulted. Yeah, there's literally nothing on here. No Windows, no nothing. So we can see that there are no drivers for the PCMCIA card. I don't think that's a problem though, because I got those disk images from that website. Thank you to whoever you are who posted those and is keeping that online. And yeah, all 8 megabytes are visible. Very cool. There's no way that this clock battery is working, right? Like it's gonna be dead. But what I find curious is that the system actually booted with that in there. Where's a ground pin? I'm assuming that's ground, or how about this? Yeah, 0.4 volts. So there's no way it's keeping anything alive with that kind of voltage. So how did the system boot? Does it like auto detect the hard drive type? And what happens if we install something like a compact flash card? Look at this, I'm noticing the Sanyo battery, it did leak a little bit. So these generally don't leak in a catastrophic way, but there's a little bit of leakage there and I should probably clean it up. I am not sure the best way to clean up the leakage, but it doesn't ever seem like it's particularly corrosive, at least not what I've seen. This is just 99% IPA here. Okay, we can pop in the fresh Duracell battery, which should give us now a nice 3 point something volts. Yes, 3.2 whatever volts. Perfect. So as for getting stuff onto the hard drive, we have a few different options. I can take the hard drive out. I could replace it with a compact flash card, but it's kind of cool that it works. So maybe it's just worth leaving it in there. But in that case, I need to figure out a way to copy stuff off of this. A USB adapter that plugs into the IDE drive, that might be one way. Or I could plug the PCMCIA card into here and try to get that working with the little compact flash adapter I was showing earlier. Or, well, of course, using this, we could plug an Ethernet card into this and I could use something like FTP to transfer a bunch of files onto here as well. We have choices, but I guess the first thing I need to do is see if the floppy drive works, because at the minimum, if we're gonna do anything on this machine without taking the drive out, we need to see if this can actually read and write floppy disks. The two things I downloaded are the utilities and whatever this is. These are 2 exe files. I'm assuming these are either disk images that when you run them, they make a disk, or they're just executable or they self-unpack. I tried using 7-zip to unzip these and that didn't work. So what I did is I stuck them both into a disk image, and I'm just gonna quickly write these using my grease weasel onto a 1.44 meg disk. And it looks like this disk is already bad, so I am going to stop using it and throw it away. I really do find that 1.44 meg disks are super unreliable. And that was an old Microsoft disk that was from Microsoft Office. Like I had a whole bunch of Office disks and they all seemed to be bad. But maybe they were stored in a really bad environment or something. So I just picked a different disk here that I had in my box of untested disks And this will tell us if the floppy drive is bad because it does verify each track as it writes it. Now, while that disk is writing, I'm just sitting here thinking that one thing I really need to worry about are leaky caps, because we have to think about 1992, 1993 when this is from. If you think about Macintoshes and Amigas, they have destructive caps all over them. We already saw that on the motherboard, which we saw with the spare one. There are no surface mount caps, or at least the leaky electrolytics. It uses all through hole. But looking at this card, it does have one here, and it looks like it has leaked. So I'm gonna need to rip those off and try to clean these up a little bit if I want to try to preserve the two cards that I have here. And the next thing we have to think about is the power supply, because also 1992, Mac Classics, for instance, their Nichicon good quality caps aren't really good quality and they all leak. So that could easily be the case with this thing as well. So I really feel like I should at least open this one up, and we should take a look in here, see if there's any signs of leakage and if there's any surface mount components, because I do see a little board here that has a bunch of surface mount stuff on it. So we might need to do that as well, just to validate that this machine is not going to self-destruct. All right, the disk is finished writing. Let's see if this thing can actually read it. So slide this thing in here. May need to clean that drive. This has all these bashes on it, but probably still works. It's an IBM. They made good quality stuff. Is there a way to skip the memory test? No, it doesn't seem like there is. Oh, it freaking works. Awesome. All right, we're gonna copy the stuff that's on the disk over to the C drive, and let's see how these work. So PS2E STRTs, that's obviously the start disk, and then we have the utility disk. IBM never embraced the whole system setup in the BIOS where you didn't need a disk. I think later with the Aptivas and stuff, they finally did, but I don't even think they made those BIOSes. I think they were like Phoenix or AMI BIOSes that they just licensed. They just loved using these disks to do the setup from every single one of the machines ever. All right, this has got to be a disk creation utility. Ah, yes, it is. Insert a blank disk. It's not blank, but that's fine. Let's just use this. The disk drive is making noises like there's an error. Diskette error. Try another. Let's try formatting this A drive unconditionally. Parameters not supported. Okay. Okay, so there is unconditional. And I guess we should specify a size. Yeah, this thing is being kind of fussy. I guess what I'll do is I'll just format this on my grease weasel, just blank it out, and then try again. All right, I created another disk. This one formatted perfectly with the grease weasel, but unfortunately, it's still giving me the same error here. So I guess we might have a bad floppy drive here. So I should, I guess, try the other one. Or because the floppy drive or the CMOS settings are not set up properly, maybe it's somehow configured for the wrong type of drive. I'm not 100% sure. The weird thing is I copied like 800, 900K worth of stuff off of a disk onto the hard drive, and that worked. So what's going on exactly with this drive? It seems to be happy, but maybe not. I just realized I could just use one of my disks here that has check it on here, and we can run a floppy drive diagnostic if it can actually read the disk, of course. In fact, let's see if I can copy check it off this disk onto the hard drive. The drive certainly seems like it's working fine. What exactly is wrong with that IBM utility for making that disk? All right, I'm gonna stick this blank disk that I made into the drive, and we're gonna do a test on the A drive here. Here we go, write test. It's fine, it's totally fine. But yet DOS couldn't format a disk. I'm confused. All right, I think I'm gonna stop faffing about here with trying to write the disk on this. I'll just grab one of my other machines, my other DOS machines, and I'll write that disk image on that machine. So it turned out the PS2E floppy drive works fine. It reads and writes perfectly in check it, but I still couldn't create the start disk. So I took the start exe and put it on one of my other machines, and I created the disk. And to avoid this particular problem in the future of someone not being able to get a working start disk, I made this disk, and then I created a disk image of this, like a regular image file that you can write with any system that has a floppy drive and a way to write disk images. I will upload that to archive.org. I'll put a link in the description. So if you have one of these machines, you need that start disk, and you don't want to go through the whole rigmarole of the exe file, self-extracting stuff, then get that disk image. So let's see if this system can actually boot this disk. Now, I should have mentioned earlier when I was talking about ways to get files on and off this machine. Obviously, I totally neglected to say that you could just use the ISA adapter here with an XT IDE as another way to very easily get stuff on and off of here. Or the PicoMem as well, because that also has hard drive images that you can use. Okay, we're getting 161 and 163. I think, yep, there it is. But it's booting the start disk. Nice, very nice. There it is, IBM Personal System 2E, machine type 9533, Advanced Diagnostics. Your error 161 is a problem with the non-volatile memory. Well, yeah, the battery died, so that's fixed now. Set the date and time before running automatic configuration. It's actually the 4th of December, and does it work with those types of dates? Seems to. Doesn't matter about the time. They've been updated. Automatic configuration is being run. This sounds very reference disky, doesn't it? But of course, the big difference is that you don't have to have these reference disks for the cards you have in here. So we can take this disk out now. It should not give us any kind of errors as it goes to boot. Interesting, we have a little bit less memory. We had 8192, I think, originally. Now we have 8064. All right, no errors. System's booting. Awesome. The system appears to be working properly, which is great. I didn't have to do any kind of repair on the main system, at least. I still want to take a look at this spare power supply to see if there's leaky caps or any surface mount caps in there that we have to worry about. But I do want to look at this quad compact flash card here, which definitely, I looked a little closer. It's got some green crusties and stuff in the corner here from this leaking cap. So let's take a look at this and see if I can get this working. And maybe we can copy some stuff onto this machine using one of these compact flash adapters. So with the camera zoomed up, you can see a little bit of the green crusties there and the vias from this leaky cap. So it's just a 47 microfarad, 16 volt thing, nothing particularly special. Let's just quickly get this thing off the board with a little metal fatigue on its legs. Wow, that came off very easily, and yep, definitely leaking. Don't see any corrosion over on this side here, so that's a good thing. Let's start with a little IPA in the area there. Could be a lot worse, the corrosion here. It is not horrible. I just don't like the green crusties there. Those vias, they don't look super great. Looks like the IPA actually kind of did the trick, but we could have some bad traces there as well. Oh no, look at that. Kind of comes clean just with the little pick here. So we'll just scratch at this a little bit. We have another via there that looks suspect. Now I'm sure you've seen like a million recapping videos on the internet, like fixing Macs and stuff like that. I won't talk too much about this other than, yeah, obviously I twist the caps off and it does leave behind the little legs here, so we kind of got to get those off. So I just use a little fresh solder and you should be able to get these off there like that. You can see the little leg there on the tip of the soldering iron. And then what's important is the solder that's left behind on the board is really corroded and kind of crusty, and you want to remove it. So we need to use some wick here to get that off. You want it to be nice and smooth. And what you're left with is some flux residue there, so we just need to get that off. I'll just use a bit more IPA. I really need a better dispenser. And we'll just use this cotton bud here, kind of clean up any mess that's left behind. There's some glue on there. Looks like they used glue to hold that original component down. You know, all things considered, this is really minor damage. So there's probably a good chance that this thing is gonna work. I'm just gonna take a look at these vias with a magnifying loupe just to make sure there's no breaks. All right, everything seems fine. I'm just scratching around here just to make sure that I get all of that corrosion. And you can see as they kind of come clear or clean, they have a kind of a copper look to them. And that's the solder resist that's coming off and exposing the actual copper underneath. Because I want any of that kind of corrosion gunk to come off, which seems to come off really easily, at least with this particular board, or however IBM constructed it here. Now, the biggest thing if you install a new cap is you need to make sure that the pads here are still connected to their vias. This is like for some voltage rail, and then you want to make sure that these traces aren't broken, but obviously we have very minor issues here. And theoretically, the issues may be with these vias and stuff like that, but I can correct that later because the cap is not going to cover those up. So one of my issues right now, and these are all my SMD caps that I have, is I don't really have anything that would work well in this application. 100 microfarad, 6.3 volts, clearly that's not gonna work. I think I'm just gonna put 2 of these on there. These are 22 microfarad, 16 volt. These are ceramic, and using ceramic in place of electrolytic type caps is not always the best idea. The problem with ceramic caps, if you look at the data sheet for these, is their capacitance value changes dramatically over the voltage range of the part. The cap that's on here, this is probably a 5-volt rail. And as the ceramic caps are closer to 0 volts, the more capacitance they have. As you get closer to their rated voltage, they actually go down in capacitance. So if I put 2 of these on, even though it's 22 microfarads, so it should be like 44 microfarads, I put them in parallel with each other. The reality is we're not even going to get that. It'll be less than that. But generally, the biggest thing you have to worry about is the voltage and the actual bulk capacitance for a rail, power rail like this, not that important. If you're using these in like RC timing circuits and stuff though, then they're not a good fit unless they've been designed specifically to use ceramic caps. Maybe for good measure, I'll put 3 of these on there. I'll just stack them up. All right, there we go. It's the little tower of power. 3 of those stacked on top of each other. As I learned with that Macintosh repair video, you want to make sure that you don't have the silver parts here touching or laying over any of the traces, because then you can lead to shorts. This is the other board. You can see that this has leaked as well. So let's just get this cap off of here in case the other one is not working. Then we can try to get this one working. Looks like the corrosion is a little bit less on this one. So we're just going to wobble this back and forth. The wiggle method, which of course metal fatigues the legs that are on there. And I'm pushing down on the board as I do this. Oh, it's already disconnected. There it is. And what we have left are some of the legs. So you just wobble those back and forth and those should come free. And I think this is still glued down. Yep, there we go. Oh, look at that. Crusties there, but this thing seems a little bit less bad off than this other board here. All right, so the question is, how do I get this card into the computer here? There's a little thing there to hold the slot bracket. There's an access place so you can get the screw in and out, just normal mounting mechanism. Okay, there we go. It's in the right position now. Of course, the riser's not installed, so that's not good. And it looks like over here on the front, it just sort of sits there. And I guess when the front case goes on, it probably holds this in place, because otherwise this could like flop around. Okay, so I'm going to pop the riser on, push down. So the riser is in and the card is in. Okay, I think that's how it works. You just kind of have to finagle it in. I'm curious if the BIOS will detect this card and make us use that start disk again. That's how it would work on a microchannel system, and you'd need to have that configuration diskette. Obviously, we don't have any configuration diskette for this machine, so maybe just running the utility and doing the auto config is all it needs. Here we go, let's power this up. And might as well just get this little compact flash IDE thing. Well, it's suddenly very unhappy, isn't it? What just happened? The machine just shut down, like as if we had a short or something. Let's see about getting this card out of here. There we go. Yeah, it's definitely easier to take it out with the riser. Does the machine still work now? Okay, it's powering up. Okay, it does. So this card is bad, I guess. Now, if we compare these two cards, I'm just looking at the dip switches. That's the same, that's the same, and that's the same. They're all exactly the same between these two cards. I think what I'll do is I'll just take this off here and I'll clean this up and transfer that over, and then we can test this other card. So I'm just gonna draw a little mark on this one because we don't know if it works. So I don't mix them up. All right, this is the other card. I've transferred over the tower of power and cleaned that up a little bit. It's not screwed in, but it is plugged in. Let's see if this thing turns on. Computer's turning on. Yes, excellent. So this one works. Interesting that the other one did not. My assumption is we have a broken trace or a bad via up in that corner there. Is this going to complain? No complaints, okay. All right, so one thing I did off camera, by the way, is I ran the util exe, the one that I downloaded off that site, and it uncompressed a bunch of files here. So the original 2 files were PS2E STRT, that was the disk utility, and then PS2E util unpacked all these files here. So there's a PS2E INST. This cannot be run. Okay, so that's a Windows installer. I'm just gonna run things randomly here. Ripple communication speed update? What does this mean? View the current speed. 4 megabits per second? What's this even talking about? 2EWLOC, that's a Windows program. PS2E wins. I'm sure that's a Windows program. PS2E lock. That's a Windows program as well. We also have drive lock, which I'm not going to run. I don't want to potentially lock the drive. PM DOS. Power down time in minutes, 10 to 20. Okay, so obviously there is a sleep mode on this computer. Oh, it's the hard drive. It went to sleep, although I put 0 for disable. And why did it? There, it spun back up again. Hey, that's pretty cool. There's obviously HDD PM OS2 and HDD PM Reg. Let's try that one. PM Reg. That's a Windows program. Okay, well, there's not a whole lot of stuff we can run from DOS other than the power management utility for the hard drive. It'd be nice if there was like a README or something like that. I'm sure in the manual talks about this stuff. All right, well, I'm just gonna try PCMCIA.sys in the config sys. It seems to hang the system. That's what this seems to do. All right, back on this page, it says PCMCIA drivers for DOS. These drivers are not as good as the ones from ISA2 slot, but the disk does have lock, unlock, and security manager utility for OS2 and Win 3.1. It looks like we have another exe I didn't download that has extra drivers, which I can see is linking to an FTP site at IBM.com. Not a good sign. These are probably not there anymore. And yeah, indeed, I'm using FileZilla here, and that does not connect any longer. It still resolves, it just doesn't connect. Okay, so this website seems to have mirrored this locally. Yes, excellent. Oh, and it downloads along with this ISA2 slot. So those seem like two different things. Cool. Incidentally, remember how it said that there was a utility to lock the cards? See these things here? These are solenoids. And I think when those engage, it prevents you from being able to eject the card. Something here will pop out, something like that. And then, yeah, these buttons become inactive. So yeah, you're able to lock any 4 of these cards with that utility. Okay, rebooting this machine. Hopefully I have a way to skip the startup sequence because configsys obviously has a thing that's going to cause the computer to freeze. And I held down shift and that did nothing. This kind of thing was a real issue with older versions of DOS. There was no way to skip that. You had to use a boot floppy. And if you didn't happen to have a disk that could boot the system and drop you a DOS prompt, you were kind of screwed. So if you're working on one of these machines and you don't happen to have a bunch of disks around to boot your system, then I would beware because like one mistake like I just made on the config sys keeps this system from booting entirely. So we're just going to delete this, which we know does not work. And now we can reboot the system. Okay, so we're just going to copy what's on the A drive to this PCMCIA directory because I'm assuming when I run this, it's just going to decompress a bunch of files. And it does indeed. That's exactly what it's doing. Oh, including a disk image. Right. All right, so to run this, we should be able to do this. And if this utility can write to this disk drive, unlike that other one, then okay, cool. What's interesting about what I'm going through here so far with this machine, it means nothing terrible, but it highlights the fact that, okay, that worked, that IBM machines are a little bit more difficult to work with just because you need these special disks and stuff like that, and sometimes getting them off of websites and making a disk isn't as easy. You have to jump through some hoops. Therefore, if you bought one of these and it was your only PC, you'd really have no easy way to make that original setup disk that I had to make because I had to use another old DOS PC to do it. And that just sort of highlights the difficulties you run into with these things. Not to mention now trying to figure out the exact combination of drivers or whatever to make this PCMCIA card thing work. It's all just a little fiddly. At least I see a doc file there at the end, so maybe that'll help us get this thing installed. Maybe this card was also available for other PS2 systems, although I don't know any other PS2 systems that had card slots that stuck through the front and the back like this thing does. But there's like IBM DOS CS.sys. Is that IBM's like MS-DOS card services driver? Maybe there's an install utility we can have here that'll help us with this. Oh, I see PCMINST.exe. PCMINST. Okay. Now remember, PCMCIA at the time was pretty early days, right? Windows 95 kind of made it where it was very easy to use and the OS really supported it. But for everything before Windows 95, and this was before 95, you really needed specific drivers to make it all work in DOS and in OS2 and stuff like that. And that's why you can't just boot from, like, say, a compact flash card plugged into this. Even on laptops of the day that had these types of cards on them, without these special drivers, they also didn't work in DOS. This was a limitation of DOS. And of course, this was new technology, right? And it's just DOS didn't understand it at the time. Okay. What's in the easygoing directory? This stuff. Maybe these are the only things that are necessary for MS-DOS to use the cards. I'll just put all these sys files in config sys and we'll go from there. Oh, they're already in here. Oh, wow, okay. Well, that's nice. That utility actually did something. Well, let's reboot then. I thought I'd have to do that manually and do a bunch of figuring out of how it all works, but nope. Oh, there it is. DOS card services, IBM. Right, resource map utility and easy play. Let's check this. Hey, at least this didn't give me that error immediately. Oh, hey, look at this. Not ready, hard disk type. How do you make it ready? Well, how about I stick another card into this thing? I'll stick it in the back slot here. Oh, I heard the solenoid click. It's detecting it. Not ready. Okay, well, this is a large flash card, like 2 gigabytes or something like that. The Cisco one that's in here is like 64 megabytes. I think I have some small cards here, and some of these are formatted. And I popped in a 128 megabyte card here, still within the capacity of working. Pop that in. Click. Made a little beep. Not ready. I guess I should hit F1 for help. So it says, you see a brief information about the card slots. Information includes driver name, vendor name, blah, blah, blah. Socket status. To see more information, press enter. That's it. And that's what we're looking at. And there's nothing here. If it's memory card, write protect yes, no, battery status, region information, IO card. Well, the only thing I can think to do here is reboot the computer. With these cards installed, let it detect them as the system boots up and see if that makes any difference at all. I did just check that this Cisco card, 64 megabytes, is formatted as a FAT file partition. There's nothing on it, but it should have showed up and worked. D, E, F, G, none of those are valid. I'm obviously missing something because we are detecting these, and it even shows whatever, STI flash 7.4, whatever, as working, and yet, why is it not ready? I wonder if it has something to do with this auto drive. Should look at this INI file. Okay, require resources. Oh, you know what? It must not support IDE hard drives. And I guess this is what's not supported, right? This thing does not have a driver for this IDE device. And who knows what 5250 is, but it says ignore anyways. SCSI seems to use the IDE port there, 140. It's like the alternate port, I think, and then we see the IRQ assigned. All right, so for now, I'm glad to know that this card is working. It sees these things. I just don't know how to get the drivers working. And I have a feeling there are probably people watching this video who know a lot more about how to get this stuff working than I do. So please comment down below, give me suggestions on how to get this working, because ultimately I do have a PicoGus that is the PCMCIA type. And I obviously have these, and I have an Ethernet card as well. And if I can get all that stuff working in DOS, well, that would make this machine pretty darn awesome. As it sits right now, I can obviously just install a regular ISA PicoGus in this thing, and I can either use the onboard IDE for a different hard drive, or I can just use this 100 meg hard drive on here, which is good enough for holding a few games and stuff. I will just put a little tick mark on this because we know that this is the working card. All right, we're gonna start with the XT IDE just for copying some files onto the hard drive, and I'm just sticking this piece of foam in here just to keep it from flopping down. Oh, wait, look at that. There's the other hard drive, the internal hard drive, WDA 2120. Oh, incidentally, we didn't try Speed 600 just to see how fast this SLC2 chip is here. Let's see what this gets us. Oh, not bad at all. I mean, I know this is not the end all and be all in benchmarks here, but that's not a terrible speed. The video speed, on the other hand, kind of sucks because even ISA 16-bit video should be like 5,500 or so characters per millisecond. So this XGA2 thing is not super performant, at least not hooked up to ISA like it is on this machine. All right, so the C drive should be the hard drive, and it is, and the D drive should be my compact flash, and it is. So I'm just gonna spend a little bit of time getting DOS 622 onto the main C drive, getting Windows 3.1 on there, and kind of getting this machine set up with some games and software and stuff, so we can run some benchmarks and kind of test this thing out, see how good of a little DOS gaming machine this actually can be. All right, things are configured and they're working well on this thing. One thing you may notice, I have the PicoGus installed, and yeah, I'm done with the XT-IDE. I've copied what I think I need over to this small 120 meg hard drive, and yep, I put this in. I haven't tested it yet, but it's ready for testing. You may also notice that there are 2 sticks of memory in here. I'm not sure about special IBM memory being required, but I just went into my memory stash and I found this 4 megabyte stick that happens to have parity memory on it, and this works perfectly in here. It works on its own, it works in conjunction with the existing memory, and with these installed, we now have 12 megabytes of memory. Earlier, when I used this startup disk for the machine, I questioned the fact that there was no setup utility on here. It just seemed to do auto configuration and reboot. Well, I have since figured out that there is a utility on here. You can boot this now, and once the system is already configured, then it allows you to run diagnostics and do some setup stuff. I actually went ahead and copied the contents of that floppy disk onto the C drive, and you can run the setup utility anytime, even from DOS here, and this is what it looks like. The system has 12 megs of RAM. It allows you to go and configure the floppy drives, and it supports a bunch of different things, external 360, including 2.8 megabyte as well, although I don't know if they made any thin laptop drives that work in this chassis like that. Drive 1 and 2, I don't know how you'd even hook those up, but maybe this is BIOS code carried over from somewhere else. Math code processor, I guess it can auto-detect if there is one, and it must be in that PGA socket somehow. Looks like you can configure the onboard serial port to be 1 or 2 or disabled if you want, and the parallel port, same thing. As for the hard drive, there is no way to configure this. I guess it's just auto-configured. And then there are some I/O address stuff for the XGA2 card and that video aperture thing, which I don't know, I just did auto config and that seems to work. So I'm just gonna leave it as is. And for the XGA coprocessor, which is like an accelerator, you can pick where in the upper memory it lives. And I'm just gonna leave it at the default configuration because that seems to work. There's also a setting on here that allows you to select whether you're caching or doing ROM shadowing into RAM. And I have that enabled for the BIOS speed up that you get from that kind of thing. I do have Windows for Workgroups installed on here, and I have the XGA drivers working. I kind of followed the guide on that website and it pretty much worked. I used the latest XGA drivers I was able to find, and here it is, it's just running. And obviously this thing has blitter and some other acceleration going on because I'm currently running the system in 640 by 480 at 65,000 colors, so 16-bit mode. And you can see that the scrolling is actually really fast. If this were done entirely with a CPU, this would not be nearly that nice. The system feels really snappy in Windows 3.1. This is actually a fine experience for a machine of this age. And when you do install the XGA drivers, you end up with an XGA setup thing in here. It allows you to configure your monitor, pick your resolution and the bit depth you're going to be running at. You can even change the font size. Here's the frame rate that we're currently running at. So I'm just running at 60 Hertz because through the capture device, that's pretty much the best thing. But you can pick display here, and there are a whole bunch of monitors you can pick from with different resolutions and stuff like that. I don't know if these custom ones actually allow you to just pick your own resolution. Let's just try that for fun. Wow, look at the resolution. It can go up to 1360 by 1024. Ah, yes. Okay, cool. So it does allow you to select different resolutions here. That's pretty cool. So 800 by 600 at 65,000 colors or 16-bit mode, not available with 1 mega video RAM in 1024 by 768. And once you go over 1280 by 960, you're limited to 16 colors, which I'm sure, yep, all of these give you. Unfortunately for Windows 3.1 here, I don't have any apps installed in here other than just like the basic stuff that's in here, Solitaire and whatnot. And I'm quite sure that sorry, I'm just getting stuck into a game of Minesweeper here. I always loved this game. And you know, to this day, I still do. I am unfortunately a little bit rusty though, and like I'm kind of stuck right here. So with these two, it's a little tricky. So this 4 here has these 3, but that means that there's gonna be one anywhere around the 4 here, an extra one. And then in these two spots here, well, there could be one there. That would satisfy the 4 and the 2. And then this 2 would be satisfied as well. So there couldn't be one in both of those spaces. And that would satisfy all of this. But then the 4 could have one like over here, for instance. I don't know. I think I'm going to have to guess here at this point. Let's see if I can figure this out over here. Same thing over here. So this 2 could be satisfied by that, as would this one, and as would that one. I don't know. I'm guessing at this point. There's probably a strategy you can do to figure out what you've done wrong here. Oh, wow. Okay. Wow, that was lucky. That was a total guess, and I got that. Wow, that doesn't really help us, though. Let's see. This should be free, 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 free. And I am stuck once again. So let's see here. That 1 has one around it somewhere, but it could be there. This, like, we could have one there, and that would satisfy those 2s. And then that 1, you know, could have one here, for instance, and that would satisfy that 2 and the 1. And then if we had one here, that would satisfy the 4, this 2. I mean, we know there's one in one of these 2 spaces here. Ah, so frustrating. And the thing is, if it's like this, that would satisfy that 1, that 2, that 2, that 2. And then the 4 would have to have one like somewhere else. Again, I'm totally guessing. Here we go. Whew, lucky. Lucky, lucky, lucky. That pretty much tells us there has to be one here, because I just guessed on that space. That satisfies that 2. And then these 1s, we can clear these out. And that means that this has to be one there, and this cannot be one. And then over here, let's see what we got. Okay, so this 2 is satisfied, so that is not one. The 3 is already satisfied. Oh, I had one in the wrong spot there. Darn it. Oh, I was so close to the end. Anyway, it's a fun game if you've never tried it. And I'm just playing here on the intermediate skill level. You can go on to expert, and then it's, you know, there's a lot more to decipher on it. Anyhow, I got sidetracked there. Windows 3.1 working perfectly. Windows 3.1, like I said, is working really well. It's very fast, but I have a feeling that Windows 95 would be really pushing it on this particular system. Probably wouldn't be a very good experience, but with Windows 3.1, it is good. And if you want to run any kind of games that are Windows 3.1 games, definitely going to work well on this system. I'd say performance-wise, you're not going to have any real issues. Okay, let's try top bench here. Just ignore that static there. That's, again, the capture device. So we're getting a score of 1111, which compares well to some random AT clone that has an Intel 46DX266 with a Cirrus Logic 5422 in a VLB slot. How is this comparing to that? That should be way faster. Video memory speed on this system is faster. The lower number is better. Opcode on this is faster. Memory speed is faster. I mean, pretty much everything is faster than this test system. I think this test system was not configured correctly. It probably had some bad BIOS settings that was slowing it down, because I feel that 109 with that configuration we see there is too slow. And that if you look at the comparable systems, a Cyrix 46DLC clone is closer to this, and that's going to be another 36SX type system. So I don't know. I think this is an outlier, this compared system here. There is enough memory to run SpeedSys. This is going to have a very slow result, but we should be able to see how much cache we have working on here, which supposedly is 16K. Incidentally, you see at the top it says VISA memory unknown. There are some VISA drivers for the XGA2 chipset, and I did try them, and I ran them with PC Player Benchmark, and while the demo was running, the colors were all screwed up. So clearly that's not very compatible with actual VISA utilities. There is our performance score of 14.6, which seems to be a little bit less than a 46DX250 and probably higher than a 36DX40. And here's the RAM speed, and you can definitely tell we have 16 kilobytes of L1 cache, which is why it was up around 30 and then dropped off very sharply. And now it's just going to continue all the way along to the far edge, because this doesn't have any L2 cache, L1 only. We can use check CPU. It doesn't really detect that this is a Cyrix chip, even though this is an IBM SLC, whatever, 2 chip. It's actually made by Cyrix. It does say that the cache is enabled in write-through mode, and we can run cache check, which does confirm. Again, we're running at 51 megahertz, and I guess 52 on the other test. I mean, 50 is probably what we're running at, but they're not the most exact tests. And you can tell with this test that we are running with 16 kilobytes of L1 again, because it's 32 all the way through until the 16 column, and then it goes up to 58. So when you're operating within the L1 cache, if code is executing in there, it's effectively double the speed as if you're accessing main system memory. Here's the results of this program. It says, looks like your RAM is really slow. Well, this is a system with a 16-bit data bus. Effective RAM read speed 220 nanoseconds, and the write speed is 430. That is very slow indeed. Let's take a look at PC player benchmark. I have to run it in VGA mode since the VESA modes don't really work anyways. As you can see, we're getting 4.8 frames per second. It's pretty slow, but ultimately this is a test designed for pretty fast systems, not 486s like this, especially ones with 16-bit data access to the system RAM, but also the video memory. Not really too bad, I guess. The system's been running for a while now, several hours, and the power supply is just kind of warm. It's power supplies on laptops when they're charging, those get super hot. This, on the other hand, I mean, I know the cover's off the top of this thing, but there's not like vents on the top of the power supply anyways. It's just kind of warm. Nothing else is particularly hot in here either. I think they really tried to pick low power devices just to keep the temperature of the whole computer relatively low. All right, let's run Cubic Player here. Should detect the Gravis ultrasound, aka the picogust, which is initialized. Yep, there it is. That did not work. I hear a solid tone coming out of the speaker, but it is frozen. I just need to double check my settings here. DMA is set to 1 and the IRQ is set to 5. I'm wondering if that's conflicting with, say, the parallel port that's in here or some other component. Couple annoyances. There's no reset button on this computer. I wish there were, because you have to power cycle it if it hard locks. And then there's no way to skip the RAM check either. It's kind of lame. You have to kind of think about, by the time 1992 came around, every other PC compatible had like a really nice flashy BIOS screen kind of showing you stuff with a logo and things like that. Meanwhile, IBM was just like black screen with a RAM count. All right, so the ultrasound variable here is set to DMA1 and IRQ5, so that does match the way the card is configured. And here in Check It, this is not like this is the be-all and end-all in information about how your IRQs are configured, but just it's a helpful guide that LPT1, which is serial port or parallel port 1, is IRQ7 normally, and IRQ4 is used for COM1. So IRQ5 is available, as is IRQ3, and I have this card set for IRQ5, so it should work. And let's just look at what it says here when this loads up. I'm gonna hit pause as quickly as I can. IRQ5, DMA1. Okay, so it's detecting it as it should. Okay, let's try this, which is a very small file. Wow, same problem. I have to say, I've never run into this. Cubic Player is very reliable with the picogust and just pretty much always works. I think for now, I'm just gonna switch over to Sound Blaster mode, and I'll reach out to Ian Scott, who's the maintainer of the picogust project, and let him know that doesn't seem to be working, at least with Cubic Player, on this IBM machine, on this obscure IBM PS2E. Changing it over to Sound Blaster mode is as easy as flashing some firmware. And for me, I just edit my auto exec here just to change it to picogust Sound Blaster, and we do a reboot. At least when you hit Control-Delete, it does not count the RAM. It just quickly starts booting the system. And let's start with the AdLib jukebox here. Make sure the AdLib sound is working. Yes, it is working. Totally fine. Of course, the AdLib does not use any DMA channels. So I'm going to change Cubic Player over to use the Sound Blaster hardware. And of course, we're talking about, regular Sound Blaster 8-bit sound, so it's not going to sound that good. Sound Blaster not found. It actually has me thinking that Cubic Player Sound Blaster support is for like the Sound Blaster 16, and it doesn't actually support the old Sound Blaster stuff. All right, no matter. We have games to try that will use the sound card. Let's first start with Fast Doom. Now, if you're not familiar with Fast Doom, it's just an optimized version of Doom for slower computers, and this is a slower computer. I'd say if you want to run Doom really well, you need to have like a 46DX266 with a local bus video card, then you're gonna get really good performance. We have sound. Where's the music? So with the fact that we have digital sound, that tells us that the picogust itself is interfacing with the ISA bus on this computer without any trouble. Should I try AdLib for the music, I suppose? Okay, yep, there it goes. And we have sound. Okay, by the way, people watch my videos and they're like, you're like the worst Doom player in the world. The thing is, I'm using this keyboard and it's like the arrow keys, none of the keys are configured the way I actually play modern Doom. When I play GZ Doom on my modern computer, you know, I WASD and I have my mouse configured for moving around and strafe and stuff like that. So yeah, I'm just not used to playing this way. Like, I think control is to shoot, and how do you even open this door? EX spacebar? Yeah, spacebar. I'm just not used to the old original DOS version of Doom controls any longer. But you can see performance is not great here, is it? All things considered. I think it's really let down by the fact that we have a 16-bit video card. That's the biggest problem here. And then on low detail, it looks like that. Yeah, I think if I were playing this as my primary machine back in the day, I would absolutely be using this low detail because this looks fine and the frame per second improvement is dramatic here. It's dramatic. Let's try Commander Keen. What's that line over on the right side? And where's our sound? All right, well, things are working well with the built-in speaker, of course. Okay, Duke Nukem has working sound. Funny thing is, I had to run MemMaker first to get this to work because there wasn't enough RAM right off the bat. I don't think this uses the Sound Blaster. I think this is just ad-lib sound. And do I remember how to play? No, not really. It's not the best scrolling, is it? Like, we could be looking at 60 frame per second scrolling, and we're not with this game. I had a lot of fun with this game back in the day, though, even with the lack of good scrolling. Okay, how about some hard driving? Now, this is a later game than this computer, 1995, as you can see here. I'm not quite sure that this game actually supports Sound Blaster, though. I think it is doing nothing. What happened? Did it freeze? This game appears to have frozen, but I'm not 100% sure this game actually works. I don't recall using this copy of it. This might just be a bad copy. I cannot blame this computer on this game not working. But I can't even hit Control-Delete. It's definitely hard locked, which means time for another power cycle, and that's where the reset button is kind of annoying. You know, it's funny, several of the things I've tried to demo here haven't actually worked. And that's just what happens when you're using DOS PCs. Sometimes there's just a whole bunch of tweaking and adjusting you have to do. Okay, here's Arkanoid 2. Yes, it does, because I'm clicking the mouse to actually change screens. All right, let's see how this looks. Oh yeah, it's good. Of course, it's delayed. I'm playing through the capture device, but it totally works. I want the laser. I want the laser. Okay, here's another Taito game, Bubble Bobble. And this is one that I happen to know really doesn't work on fast computers. I think it has ad-lib sound. Yes, I do. Okay. Remap? No. Okay, so the music is fine here, but let's see if the gameplay works. If I can figure out how to advance. We'll know in a second. On faster computers, this game is too slow. It's like the opposite problem of what you would expect. Oh, it's fine. Oh yeah, okay. So this machine is not too fast to play Bubble Bobble. Anyhow, as I was saying, I think this machine is really good for games in that era. Now, say Wing Commander, that game is very speed sensitive. This may be too fast, but it might not be, because that really plays well on the 386DX, maybe 25 megahertz-ish speed. But one of the issues is you can't really control the speed of this machine, so if it is too fast, you're kind of stuck. Now, it does bring me to the fact that I think this is a Cyrix 486, although I guess it's not. I was going to try this utility here that allows you to twiddle with some of the settings here. Yeah, it locked up the system here of the 486 DLC processor. I thought that's what was in this thing, but I guess it's not. With the Cyrix version of this chip, you can like control the cache bits and turn off the L1 cache. And of course, if you do that, it slows it way down, which is particularly good if you need to play a game that is too fast because, you know, of the cache or whatever. So I did a quick search for IBM 46 SLC2, and it says, is anyone familiar with Cyrix? The SLC name may sound familiar, and IBM sometimes made chips for Cyrix. For that matter, as part of the agreement, IBM sold half the yield under its own name, but that's not where the 46 SLC came from. IBM also had an agreement to make chips based on Intel's designs. IBM made 46 chips based on Intel's technology, and you can find conventional socket 3 Intel 46s with branding on them saying they're made by IBM, and sometimes IBM did strange mashups with the technology. That's where the SLC was. IBM took the 36SX chip, put a 46 processor core in it, clock doubled it, and doubled the cache to 16K to make up for the 16-bit data bus. The result was what everyone assumed was a 46SX, but it wasn't. Performance-wise, it was a little bit better than a 33 megahertz 46SX, which is a true 32-bit processor, and it was cheap to make. The SLC stood for super little chip. All right, well, today I learned that the 46 SLC2 is not a Cyrix chip, because I swear I've heard IBM selling their branded chips that said IBM on them, but they were actually Cyrix chips. This is actually based on Intel technology, and it's a 46 core shoved into a 36SX. Wow. Okay, before I do my final conclusion on this machine, what I would like to do is I'm going to move this out of the way, and we're going to take a look inside this spare power supply just to see if there's anything in here that needs addressing. I don't smell any kind of bad caps, and this thing's been running for hours without any issues, but I just want to check if there's no like leaky SMD caps in here especially. All right, well, there are some screws on here you can take out to try to get this apart, but I was trying to pull this apart and it wasn't quite coming apart, and that is because there's a rivet right there. I'm going to have to drill that out. That rivet is holding on this top cover. That was pretty easy. That came right out. So interesting here, you can see there's thermal compound. That actually touches the metal chassis here, and this obviously heat sinks the main switching component, which gets hot, into the metal chassis here, this entire frame. So that's one way it avoids having a fan. So far so good, no signs of any leakage. We're gonna have to pop the board out and flip it over just to check the other side. And I also don't see any potentially leaky caps on that little board there, that voltage regulator board. That is cool. Concerning are these brown caps here. These are similar looking to the ones that are in the Macintosh Classic, and they always leak. So that's potentially not great. This is a pretty compact power supply as well, which means heat could be possibly getting to those. Construction quality seems okay. Let's see here. I don't think there's any leakage. Nope. This looks good. Immediately, I don't see any broken solder joints either. Things look good. The caps are all up in this area here. I'm of course not saying that it won't ever leak, and this is from the 90s, and things got kind of crappy in the 90s when it came to capacitors. So if you have one of these and you really want to preserve it for absolutely forever, the thing you might want to do is just change these caps out. I'm noticing these are 1800 microfarad. That's a kind of unusual value, or it's not unusual, but it's not as common as some of the other ones. But I think one of the issues with this is these caps have to be a very specific size, height, and width to fit in there. And you can see how they're tilted over there. Even IBM struggled, or whoever made this, struggled with the size of those parts there. If you have one of these that won't start, I'm going to say probably one of the things to check is a fuse, if there is one. Yep, there's a fuse right there. If that fuse is not blown, then probably you want to check these little small electrolytics over here. Just make sure that they are still within spec. A lot of times the power supply won't start simply because these have lost some of their capacitance and there's not enough reserve there to start the controller. While reassembling this, you might want to clean off and reapply the thermal paste. This stuff was actually pretty good. Not much on there, but that's what they put on from the factory. So you might want to reapply that, and then new zip tie, and there it goes. Things all back together. Now in this day and age, we have small form factor computers everywhere. They are super common. And then probably the Mac Mini was maybe one of the first really popular ones that came out with the G4, I think. And then there's a whole series of Intel and Intel NUC and all this, that, and the other thing. But back in 1992 when Intel or IBM was designing this thing, that was not the case. And when this thing was released in 93, I think it was really pushing the boundaries. IBM took a bunch of laptop stuff, low power CPU, low power everything, stuck it in a desktop case, gave it expandability and industry standard expandability at that, no proprietary junk. 4 PCMCIA slots with 2 of them available right through the front here. I think it's a really novel and innovative machine. It doesn't have a fan, so if you have a quiet hard drive, the thing is really quiet. I mean, imagine they offered a diskless version of this that had network booting. That thing was silent. How awesome is that? That is very different than all of the other computers that were available at the time. IBM was really ahead of the curve, and it seems that people didn't really appreciate that, or maybe they just charged too much for this because, you know, IBM, right? So they only sold, what did it say, 20,000 of these? So they're probably pretty rare. If you have seen some of these around or you happen to have one, let me know. I'm really curious. I don't think I've ever seen any other videos about this machine. And yeah, reminder, if you do have one and you have that PCMCIA card in there, you got to take that cap off there and try to clean up that corrosion. Otherwise, you might end up like one of mine where that card doesn't even work. Which brings me to the next thing. If you happen to know how I can better utilize that PCMCIA card, also let me know. I would love to be able to use compact flash cards to easily get stuff on and off of this thing. And of course, I can use the Pico Gus card that plugs into the back. I mean, that's a good solution as well. Now, that reminds me, the Pico Mem here, I've shown this on the channel before. This thing has a Raspberry Pi Pico with wireless support, SD card slot. I think Freddie, who's the maintainer of this project, told me that Sound Blaster support was coming to this card. And since I couldn't get Gravis Ultrasound support working in here, at least with Cubic Player, I didn't test it with other games, the Pico Gus in here is really just emulating a sound card. And well, if this thing can do that, but also offer storage and networking through the Wi-Fi chipset on here, this is probably a better solution for getting this thing, well, expanded and online. This thing has really been a pleasure to use, and I absolutely love the small form factor. Windows 3.1 is nice and zippy. XGA2 has hardware acceleration, so you get blitter and stuff like that on there, which makes it very usable. If you're looking for a machine in the 386/486 era, and you don't have a lot of space to have a big box or whatever on your desk, this is actually something I could recommend. And I don't say that a lot about IBM stuff, at least the later stuff, just because IBM stuff is usually very finicky and annoying. But this one, on the other hand, doesn't seem to be either of those things. I'm not too sure about the reliability of this computer. Obviously, we don't have a large sample size. I do have those spare parts, which I didn't actually test, so I don't know if those work or not. But this computer just worked out of the box, so I didn't feel like I needed to actually do anything more. But since this computer worked out of the box, I think I'm just going to stash those spare parts away. They don't take up a lot of space, so that if this computer ever does break, well, then I can bust out those spare parts to try to do a repair. Anyhow, I think that's going to be it for this video. So yeah, what do you think about this machine? Let me know in the comment section. And if you liked this video, I'd appreciate a thumbs up. But if you didn't, you know exactly what to do. Subscribe if you haven't already, and a huge thanks to my supporters. They make it possible I do this full time. Their names are scrolling up the side of the screen over here. You can become a supporter at the links down below, YouTube memberships, Patreon, all that kind of stuff. And I think that is going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.